Hello, Algebrites. On this beautiful day, you are going to be able to write and solve absolute value equations and inequalities. Now, for this video, we're going to focus on the equations, and the next video, we will do inequalities. So, let's work through the warm-up real quick. Go ahead and read that. Pause this video, read through this, and see what you come up with. And we are back. A cereal company produces a box of math flakes that weighs 18 ounces. And notice, they print on little math symbols on each flake. What a glorious thing. However, the company allows a little more or less product per box by about 0.5 ounces. Why might they allow this tolerance? Write a compound inequality that describes the minimum and the maximum amount of product per box. I'm going to start with the actual compound inequality, and it's an inequality. So I'm going to use the M for math flakes, and let me talk about the minimum here. Minimum. So notice that it's going to be 18 ounces minus 0.5, but what symbol am I going to use right here? Well, notice it's got to be greater than, or it's allowed to be up to half an ounce. So that's why we have greater than or equal to. So when I do that arithmetic, 17.5 ounces. Now, what about the maximum? Maximum is going to be virtually the same, except that it's going to be 18 plus half an ounce. And notice that this symbol is going to be different because it can only get up to 18.5, but not greater than. So it's got to be less than or equal to 18.5 ounces. Now, when we talked about compound inequalities, we always had the word and or the word or here, right in between. So which one do we use? Well, notice what we need is the box has to have at least this and at most this, and at most. So it's actually the word and is in between. So here is my final result. All one. So it's all the numbers that are between 17.5 up to 18.5 ounces, including those values. So the next question is, why might a company allow tolerance? Well, tolerance permits the company to save money and time. Saves money and time. What do I mean by that? Well, if they had to have exactly 18 ounces, what does that mean? 0.0000000000, and when does it stop, right? Way over here. So that means we're getting into not just crumbs here, not just crumbs right there, but like getting into the atoms. So nobody has time or energy or money to actually get exactly 18 ounces. Just way too much time and money. So that means they allow some tolerance because it saves them money and it also saves them time. They want to have a small tolerance so that you always get, when you are a customer, you always get what you expected, about 18 ounces. And they don't want to go over because they don't want to be giving away product. And they don't want to go under because they don't want to be lying about their product. All right, so now let's see how this one statement can be written as a single statement. Notice this is compound. We've got two things. So we're going to look at today called absolute value equations. And the next video we'll look at inequalities. So we're going to solve each absolute value equation. And what steps did you use? So think about this one right here. The absolute value of x is equal to 4, which means there is a number that when you put this in, you get 4. And some of you might say, oh, I know that one. That is quick. X is 4. Well, what's the other option besides x being 4? Oh, x could also be negative 4. Good. And notice we're going to put the word or here because there is no number that is both of these at the same time. So I'm not going to say and. You can't be 4 and negative 4 at the same time. But you can be 4 or negative 4. Okay, so conceptually, what just happened? To get from this step right here, well, first off, notice that the bars essentially mean that it splits. How do I get rid of the bars? I have to split the absolute value into two separate equations. Why? Because there are two values that I can substitute in. Okay, now how do I get the first statement? Well, if I just erase the bars, I get x equals 4. So how do I get from here to here? Well, notice the x, or the left side, stays exactly the same, but the right side becomes oppositified. Not a real word, but there you go. So those are the steps, actually. So let's look at the steps here. Isolate. The first thing we're going to do is we're going to isolate the absolute value. Isolate the absolute value, which means it's going to look like this. We've got absolute value, and you've got a bunch of stuff inside, is equal to, and you've got a bunch of stuff over here. So notice what we don't have. You don't have any numbers or letters or anything outside the absolute value on this side. Okay, once the absolute value is isolated, we can split into two equations. Now, one of them is going to be a positive version, and the other one's going to be a negative version of it. And notice up here again, one is a positive version and one's a negative version. Or, better yet, the original version, and then the opposite. Okay, next, we solve each equation. Each equation. Let me point out up here, too, that the bars are gone. Drop the bars. The absolute value bars are now gone. So that's the point of the split. The split gets rid of the bars. And lastly, we're going to check the solutions. Okay, so number one, isolate the absolute value. Then we're going to split into two equations, a positive version and a negative version. The bars are gone now. We're going to solve each equation, and then we're going to check the solutions. All right, now that we have those steps, let's take a gander here. But wait a tick. We got to watch out, because math is not about only following steps. We have to be logical about it. And we ask ourselves, what absolute value, so the absolute value of what number is equal to a negative 8? And the answer here is not, don't just start doing this rote and say, oh, well, we have a negative 8 or we have a positive 8, okay? Wait, but Swenson, you just told me to split. But always be logical, always be logical. This doesn't work. Why? Because when I substitute a negative 8 in, I get a positive here. When I substitute a positive 8, I still get a positive 8. So what is this? Well, the answer here is no solution. Why? No solution. And the reason for that is because absolute value cannot be negative. Not inside, but the result cannot be negative. And let me pause here and explain real quick what's the difference and what is absolute value. So that's a great place to stop here. So if we have a number line here and we have 0 right there, and let's say I have some number here, a, and over here we have the opposite. And let me make that equidistant-ish, like so. Okay, so notice here, this is a number, a, and the opposite of a is over here. So a is a point, and negative a is also a point. They're locations, okay? And what does it mean? Well, opposites are on the other side of 0. So negative a is the opposite of a, and a is the opposite of negative a. It's just on the other side. And when I say other side, I mean directly the other side. It's got to be equidistant here, the same distance on both sides. So the distance that we're talking about, from here to here, the distance is a, and from here to here, the distance is also a. This is the absolute value. The absolute value is the distance, is equal to the distance to the point. So when let's throw in a number here. This is negative 8. This is positive 8. So what's that mean? These are both locations. 8 is here, negative 8 is here. They're opposites because they're the same distance to 0. The absolute value is how far is this number, this point, away from 0? Oh, it's 8. And how far is this point away from 0? Oh, it's also 8. So those are the absolute values of these two numbers. So that's why we can't ever be negative. Why? Because distance can't be measured negative, at least without direction. Okay, so now let's take a gander and solve each of these problems together. Okay, let's take a gander here. Our first step here is, again, we need to isolate the absolute value. The first major step is to get this by itself. And notice that I have the plus 5 that I need to get rid of. So let me go ahead and do that. I'm going to subtract 5 from both sides. Bring down the absolute value. Please make sure your absolute value symbols are larger, because if you did this, it might look like a 1D1 or an LDL or something like that. So beware of that. And the same thing here. What if I said 131? Well, does that mean the absolute value of 3? Or is that 131, right? So make sure your handwriting is clean enough to understand. All right, so now I bring down the arithmetic there to get 8. Oh, look, that's the same. Never mind. All right, and now we split. Step 1, isolate the absolute value. Step 2, remember, the bars go away. D is equal to 8, or D is equal to negative 8. The bars go away, and here are my two solutions. Now let's just double check to make sure that this works. So I'm going to check both of them. So the absolute value of positive 8 plus 5, does it equal 13? So the absolute value of 8 is 8 plus 5. Does that equal 13? We don't know yet. 13 equals 13. Dun, 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 dun. Done. Now what about the other one? The absolute value of negative 8 plus 5. Does that equal 13? Well, this becomes 8 plus 5 is 13. And now we finish it up by concluding that 13 does equal 13. Woohoo! And we have checked it. So first we isolated the absolute value by moving this 5 to the other side, subtract 5. Then, step 2, we split it into two equations, erase the bars to get one of them, and then the other one, we take the opposite. And if there's more to solve, then we would have done that. Lastly, we check them. Okay. Let's work now through B. Well, notice that step 1 is actually done for us. Look, absolute value is equal to. So step 1 is already done. So step 2 is to split into two separate equations. Okay, remember the first one, just erase the bars. Do not make any changes. Look, don't make this into a positive. We're not taking the absolute value. We're saying, what stuff can I throw into there? So I get rid of the absolute value by splitting. Now the word or. Now everything stays the same here. Look, exactly the same. 3c minus 6, 3c minus 6. So nothing changes. Don't change this. Don't make this into a positive either. Now, we do exactly what we had before. It's equal, but now it's a negative 9. Good. No more bars. Bars are gone. Okay, now we're in the position where we can do step 3. We're going to solve this one and solve this one. So we can just focus on one of them and do what we normally would do. I'm going to add 6 to los dos lados, both sides. So bring down the 3c, and that's going to equal 15, and divide by 3. And notice, you don't need to write what I did in red, but if it helps you, word to your grandmother. C is equal to 5. Now don't forget to bring down the or on each step here. Bring down the or on each step. Now let's focus on the next one here. I'm going to do exactly what I did before. I'm going to add 6 to both sides. Dun, 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 dun. Bring down the 3c is equal to negative 3. And now we divide by 3, and we see that c is equal to negative 1. So here are the two options right now. Is that c is equal to 5, or c is equal to negative 1. Notice I'm bringing this in as a single answer. What do I mean? One answer with two solutions. The 5 works, but so does the negative 1. So altogether, this is one answer. Okay, so let's give it a check now. Let's check this first one right here. So bring down 3, but instead of c, let's put a 5 in, minus 6, and does that equal 9? And then the next one over here, 3. This time we're going to multiply by a negative 1. And make sure we copy it down exactly. And notice what I'm doing here. I'm not splitting. I'm just substituting back into the original problem and simplifying that. Don't do any splitting because I'm checking. All right, so now continue on here. 3 times 5 is 15 minus 6 equals 9. Then 15 minus 6 is 9. Keep the absolute value. I haven't used it yet, and now I use it. And like Kleenex, I can throw it away. 9 is equal to 9. I've used it. Check. Now what about this one over here? 3 times negative 1 is negative 3. Bring down the minus 6 equals 9. Now I can simplify inside. Absolute value of negative 9. And now we see that 9 is equal to 9, and that's a check also. So we see that both the answers work, both solutions. C is 5 and C is negative 1. All right, now let's take a gander at a little more complex problem here. Notice all the steps are involved right here. Again, step number 1, we need to get the absolute value by itself, okay? Which means in this case, I need to get rid of this 6 plus in the front. And by the way, this is a positive 6 right there. It's a positive 6. So I need to get rid of that positive 6. I'm not deciding to subtract the 6 from both sides because of this plus. I'm going to subtract 6 from both sides because it's positive. Okay, so I'm going to subtract the 6 because 6 minus 6 is 0. Whatever I do to one side, I'm going to do to the other. And now I bring down the absolute value, 2 minus 4x, absolute value is equal to now 10. And now this is where we split, okay? The absolute values are by itself. The absolute value symbol is by itself. So I just erase the bars and that's it. That's for the first one. And for the second one, put or. Remember, the left side is exactly the same, but the right side is opposite, negative 10. Now let's solve each one individually here. So subtract 2 from both sides because the 2 is positive to begin with. Again, I'm not adding 2 because of this negative. That's something different. Okay, now I bring down the negative 4x, and over here I get an 8. And now divide both sides by negative 4. And I'm going to get 8 is equal to negative 2. Don't forget to bring down the ors here. And let's finish up this one here. Again, I'm going to subtract 2 from both sides. And I'm going to bring down the negative 4x is equal to negative 12. And now we divide both sides by negative 4. And in the end, we get x is equal to positive 3. So here are my two options. Is x is negative 2 or x is positive 3. And now let's do a check. So I'm going to say 6 plus 2 minus 4 times a negative 2. And does that equal 16? And then the other one is going to be the same, but I'm going to put a 3 in instead. So 6 plus absolute value of 2 minus 4 times 3. And does that equal 16? So let's just do this first one here. Bring down the 6, bring down the absolute value. The 4 times negative 8 is negative 2 is a negative 8, equals 16. All right, continue on. 6, bring down. Now notice this, the double negative is a positive, so it's 2 plus 8. That gives me a 10 inside. Notice, again, make the absolute value bars larger so it doesn't look like a 100 or something like that. And bring down the 16, and now the absolute value of 10 is 10. And finally, we get 16 equals 16. Notice this is where I stop. Don't stop here. But Swenson, I know this is true. Right, so if you know it, then write it. All right, and now let's check for the other one, which is 3 here. And does that equal 16? So bring down the 6, and bring down, and so 2 minus a 12 inside the absolute value. Bring down the 6 again, and inside I get negative 10. And now we get 6 plus 10 is equal to 16, and lastly 16 equals 16, and that does indeed work. So notice that the checks actually seem a little bit longer than the original problem here. So just want to warn you that you're going to need lots of space when you're working on things because it's good for you to check. It's good for you to check. Please take a moment now to work on these problems here. And don't forget to check your work. The last thing we're going to do is we're going to walk through an example of an application, very similar to what we started off with. A company makes 2-inch screws and allows for a tolerance of 0.1 inch. Write an absolute value model that shows the shortest and the longest screw lengths. Then solve to find the shortest and the longest lengths allowed. Okay, this one does require a little bit of background here. And so I'm just going to show you how one might set this up. We're going to use a basic formula here where I'm going to say this equation here. The absolute value of x minus a is equal to b. Now, what does each thing mean? This x here is the actual length of a product, okay? Or the actual weight or whatever we're talking about. The a is the target value or the average, okay? So in this case, a is, this company is making a 2-inch screw, so that's going to be the a here. That's their goal, and on average, all the screws should be 2 inches. Okay, and lastly, b here is what they permit, the tolerance that they allow, or the difference, the plus or the minus, right? Plus or minus, like, how old is that person? He's 40, plus or minus 2. Well, plus or minus is sort of the tolerance that we allow. So that's what this is going to be. Okay, so the setup is actually fairly straightforward. We do x, or whatever the product is, maybe s for screw. My s's look like 5, so I won't use that. And the target value is 2, and is equal to the tolerance of 0.1. Now let me explain this, what it means. It means when you measure a screw, you just made a screw. Okay, and now let's measure it against the 2-inch, the exact 2-inch screw right there. Okay, and now what happens? When you measure it up, the difference that is permitted right there, the biggest that it can be, is 1 inch, okay? Now that means this one's too big, but it's okay. It's larger, but it fits within. You might also have another screw that's right here, like so, and notice that it's gonna be a little bit maybe too small. And so, again, if that tolerance right there is at 0.1 or less, then that's going to work. So we can have a screw that's a little bit larger, a little bit smaller, or spot on. But if it were too small, so for example over here, and then this one was, the gap here was 0.2, then they would have to melt that down and do it again, okay? If this one was too large here, then they would have to keep filing it down or melt it down and try again. Okay, so here is the absolute value model, done. And now let's solve it. We solve just like we do above. We split this into 2 separate equations, or x minus 2 is equal to negative 0.1. And now we solve individually. I'm going to add 2 inches to both sides, so that means the largest value is 2.1. The other option is, when we add the 2 inches to both sides there, we get a 1.9. So this is my maximum here, and this is the minimum. And if there's anything that's outside this, 1.8, 1.89, and over here 2.1, 1, 2.2, then they're going to have to start over or make adjustments. And there we go. So please take a moment here and work through the original warm-up problem there.